On July 6, 1962, the United States government buried a 104-kiloton hydrogen bomb 635 feet under the Nevada desert and pressed the button. 3 seconds later, 12 million tons of earth went airborne. A dome of soil lifted nearly 300 feet before it ripped open, and when the dust settled, the crater was 1,280 feet wide and 320 feet deep. That is wider than 4 football fields and deeper than a 30-story building. And here is what nobody talks about. The entire point of that explosion was to prove that a nuclear bomb could do the job of a Caterpillar fleet. They called it Project Plowshare. The government spent $770 million and fired 27 nuclear detonations from 1961 to 1973, trying to prove that atomic bombs could dig canals, carve harbors, and move more earth in 3 seconds than 1,000 bulldozers could move in a year. It did not work. The fallout from that single shot in Nevada reached Iowa, South Dakota, and Illinois. The Department of Health and Human Services later ranked it the second largest contributor to American radiation exposure from the entire test site. 13 million people received measurable doses. The program died. The bulldozers kept their jobs. But the machines that came after had a problem no Caterpillar engineer ever designed for. January 27, 1951. Yucca Flat, Nevada. The first nuclear weapon ever detonated on this patch of desert lit up the winter sky 65 miles northwest of Las Vegas. The mushroom cloud was visible from the hotel rooftops on the Strip. Over the next 11 years, the Atomic Energy Commission fired 100 atmospheric nuclear tests across a piece of ground roughly the size of Rhode Island. 1,350 square miles of federal desert, fenced off, with nothing around it but creosote bush and silence. Every single one of those 100 detonations left a mess on the ground. Twisted tower steel fused by blast heat. Contaminated vehicles that had been placed as test subjects. Shattered concrete from the instrumentation bunkers. Miles of irradiated data cable. And thousands of tons of plutonium-laced desert soil mixed into the alkaline dust layer by layer, shot by shot, for over a decade. The internet claims that Caterpillar D9 bulldozers were placed at ground zero as test targets. We checked the declassified shot reports from the Defense Nuclear Agency. Every single test array is documented. The targets were houses, sedans, fire trucks, ambulances, trailer coaches, electrical transformers, file cabinets, and mannequins dressed in civilian clothes. Not one indexed report lists a D7, D8, or D9 bulldozer as an instrumented test article. The construction equipment was not the target. It was the cleanup crew. And that is the part of this story that nobody tells. If you want to see what happened when those machines met the most radioactive ground in North America, like and subscribe. It takes 2 seconds, and it tells us these stories matter. In August 1963, the United States signed the Partial Test Ban Treaty, and the atmospheric mushroom clouds over Nevada stopped forever. But everything they left behind stayed right where it was. The Atomic Energy Commission looked at Yucca Flat and faced a question that had no precedent. How do you clean up the aftermath of 100 nuclear explosions? Their answer was almost poetic in its brutality. Underground nuclear tests had been punching holes in the desert since the early 60s. When a device detonates at depth, it vaporizes rock into a cavity. The roof collapses, and the surface drops into a circular depression called a subsidence crater. Yucca Flat is covered with them. Hundreds of perfect bowls punched into the desert by bombs that had already gone off. The AEC looked at those craters and saw ready-made graves. Starting in the mid-1960s, heavy equipment crews began pushing the atmospheric era's contaminated debris into the underground test craters in Area 3. The Department of Energy confirmed this in writing, using the exact words, "scrap tower steel, vehicles, and other large objects that had been subjected to atmospheric testing." 7 craters became permanent disposal cells. 2 adjoining craters were typically joined into a single unit, with the soil ridge between them used as fill material. The primary machine was the Caterpillar D9G, 385 horsepower, 45 tons, running a U-type blade configuration designed to contain large volumes of loose material in a single pass. Supporting it was the D8H at 270 horsepower, assigned to fine grading work near the unstable crater rims where the heavier D9G could not safely operate. The ground near a subsidence crater is unpredictable. Massive underground voids sit beneath the surface, and engineers posted setback lines measured not in feet, but in caution. The operators wore dosimetry badges on every shift. Small photographic film packets recorded cumulative radiation exposure. Crew rotations were controlled in 2-hour cycles. When one operator dismounted, another took the cab. The D9G ran continuously through daylight hours. But the real enemy was not the machine or the ground, it was the dust. Plutonium particles embedded in disturbed desert soil became airborne during every blade pass. Canvas face masks could not fully stop them. On high wind days, all earth-moving halted under standing orders from the Atomic Energy Commission. Some weeks the machines sat idle for 4 consecutive days in the desert heat, while the wind carried contaminated dust across the flat. And here is the detail that everyone missed at the time. At the edge of Mercury Base Camp, the main forward operating base at the Nevada test site, there was a checkpoint called RAMATROL. Every piece of metal leaving the forward areas had to pass a radiation swipe test before it could cross that line. Equipment that cleared the test could be sold through normal government surplus channels. Equipment that failed could never leave. The contaminated machines stayed inside the fence, held in the forward area until on-site disposal was approved. That policy meant one thing: some of those bulldozers were never coming home. By the late 1960s, the Area 3 disposal craters were receiving close to 1,000 cubic yards of contaminated material per working day. A low dust cloud hung over the crater zone, while diesel exhaust layered through the haze. The D9G undercarriage absorbed the worst contamination. Trackpads packed radioactive soil into pins, bushings, and roller assemblies with every push cycle. Washdown crews hit the machine from the bottom up after every operational period, spraying water under pressure onto the blade, tracks, and undercarriage. Runoff collected in lined sumps. Nothing left the site boundary unchecked. This is the kind of story that disappears if nobody watches it. Like and subscribe. Between 1979 and 1990, the program expanded. Scrapers and motor graders worked alongside the D9Hs, cutting and loading contaminated soil across the broader Yucca Flat Basin. In 1995 and 1997, plutonium-contaminated soil from the double tracks and clean slate sites of Operation Roller Coaster was excavated and trucked into the Area 3 craters from Tonopah, over 100 miles away. The craters swallowed it all. And then the machines themselves started going in. The D9G that had spent years pushing irradiated debris across Yucca Flat was eventually pulled off the line. Its undercarriage was too contaminated for standard resale. Decontamination procedures could not bring it below acceptable levels. Under federal regulations, a machine that could not be cleared was reclassified as radioactive waste. Radioactive waste at the Nevada test site went into one place: the craters. The bulldozers were buried in the same holes the bombs had made. The tool and the task became inseparable. Today, the 7 disposal craters in Area 3 are capped with clean fill, graded level, and continuously monitored. From the surface, they look like ordinary desert ground. Beneath them lies everything those machines pushed into place over 3 decades, plus the machines themselves. 10 miles away, the Sedan crater sits on the National Register of Historic Places. Roughly 10,000 visitors a year stand on a wooden observation deck at the rim and look down into the largest man-made crater in the United States. They are not allowed to bring cameras or binoculars. They ride a government bus with blacked-out route maps and sign a liability waiver before they board. And in Area 7, there is something most of those visitors never see. A 157-foot test tower with a crane still attached, built in 1992 for a joint United States and United Kingdom nuclear test called ISACAP. The shaft is drilled. The wiring is in place. The shot was cancelled by the testing moratorium before it could fire. Everything is still standing, exactly as the crew left it over 30 years ago. The Nevada test site absorbed 928 nuclear detonations between 1951 and 1992. 100 were in the open air. 828 were underground. The contaminated equipment from the atmospheric era was pushed into the craters left by the underground era, and the machines that did the pushing joined them when their own radiation levels made them unfit to leave. The United States government has paid more than $2 billion to former Nevada test site workers and their families under the Energy Employees Occupational Illness Compensation Program. That covers cancers, lung disease, and conditions linked to radiation exposure. It covers scientists, contractors, and the laborers who ran the machines. The craters are sealed. The caps are graded. The dosimetry records are filed in a federal archive. But somewhere under Yucca Flat, the Caterpillar D9G that spent years pushing the atomic era underground is still sitting in the dark, blade down, buried in the same ground it was built to move. Like and subscribe if you want more stories like this. Tell us in the comments, did you know bulldozers cleaned up America's nuclear test program? We will see you in the next one.